Section S8 is about probability, and the basic idea is pretty straightforward. Most people pick it up very quickly. The idea is that when you're trying to figure out the probability of some event happening, you start by counting the total number of things that can happen in the situation that you're talking about, and that's your denominator. And separately, you figure out the number of different ways the event you care about could have happened, and that's the numerator. And for any probability that you get, the answer that you get as your result always needs to be between 0 and 1. That's essentially, remember, 100% is 1, and 0 is 0%. And if something is guaranteed to happen without a doubt, then the probability is 100%, and nothing can happen more likely than that. On the other hand, if something is completely impossible, then the probability is 0%, and you can't have a probability less than that. So one of the things professors look for when they're checking to see if a student has a right answer to a test question is, first of all, is their answer between 0 and 1? If it's bigger than 1 or less than 0, then the student clearly did not understand what they were doing. So make sure you double check at the end of a problem to make sure that your answer is somewhere between 0 and 1. The numerator should be less than the denominator. Well, it could be equal if something has a 100% chance of occurring. I'm going to work a couple of different examples to illustrate some techniques and ideas, but for the most part, this first little equation at the start, that pretty much tells the whole story. So here's an example to kind of nail down how that formula works. If you're rolling 2 dice, which frankly is a pretty common thing in a lot of gambling games, what is the probability of getting some total? Like in this case, it's a total of 8. The beginning of a problem like this is to figure out what your denominator is going to be. And if you're rolling 2 dice, the first die has 6 possible results. That's die number 1. And the second die has also 6 possible results. And whatever happens on one die is completely independent of whatever happens on the other, so there's really 36 possibilities. The first die could get a 1, and the second die could get a 1, 2, 3, 4, 5, or 6. The first die could get a 2, and the second die could be 1, 2, 3, 4, 5, or 6, and so on. So that's your denominator. The numerator here is a little tricky, and this is one of the key challenges in probability questions. You have to double check your own thinking to make sure you're not being lazy. What I mean by that is, when we talk about getting a total of 8, people will try to consider what are the possibilities. And they might think, well, 4 and 4 would equal 8. What other possibilities are there? Well, 3 and 5 could make 8. 2 and 6 could make 8. 1 and 7, oh wait a sec, if we're on regular dice, 1 and 7 is not a possibility. So sometimes when people are thinking this through, they're thinking a little too abstractly, and they count through the possibilities like this, and they think the numerator is 3. This is not being specific enough. This is not being careful enough. If you think there are only 3 possibilities, you're missing something. You might want to be a little more organized about it and list out the possibilities based on which die rolls which number. So 2 and 6 and 6 and 2 are actually 2 different possibilities. It's the same 2 numbers, but you've got a different die rolling the 6 and a different die rolling the 2. You get the same thing with the 3 and the 5. 5 and 3 is technically a different possibility because it's a different die coming up with 3 and a different die coming up with 5. Now, 4 and 4 only has one possibility because if you switch them around, it's the exact same results. So there are actually 5 different results that would give you a total of 8. So the probability here would have a numerator of 5 and a denominator of 36. If you could reduce that fraction, then please reduce the fraction. We shouldn't need to include that in any of the directions telling you that simplifying your fractions is required. By this point in math, that should be automatic. This way of doing the problem that I just did here is often the only way you can do a problem, where you have to work out the denominator sort of generally, thinking through the total number of possibilities, and you work out the numerator very carefully but also fairly generally. But sometimes, like in this case, there is an alternative. And the alternative technique is something where you actually write out what's called the sample space. That's important vocabulary you're going to see a lot when you're talking about probability questions. And basically, the sample space is where you write out all the possible results that could ever happen. So here, a good example of a sample space, an organized way of writing up a sample space, would be to list all the possible results for each die and make a chart out of it. Because you could actually write out every possible result that could ever happen. If you're talking about situations that have lots of possibilities, not just 36 different results, but hundreds or thousands or tens of thousands of possibilities, this idea becomes a pretty bad idea to try to write out the whole sample space. But if you have something like this, where the number of possibilities is not really that big, then actually writing them all out is probably a good idea, because it helps you see what the total picture is of everything. So the sample space, and you'll sometimes see this like when you're flipping coins or rolling dice, because the number of possibilities are not really that big. A sample space is this type of thing, where you have all the possibilities written out in one picture, in one list, or a chart, or something, where you've got every possibility written out. When you're looking at a sample space, it becomes a lot easier to see, oh look, there are 5 different ways to get an 8 out of 36 possibilities altogether. You don't actually have to consider it abstractly. You can actually point to them and see 1, 2, 3, 4, 5. Look, there's 5 possibilities. So sample space is a good technique for small situations with few possibilities. Unfortunately, most interesting probability questions involve sample spaces that are way too large to ever write out. And a really good example of this type of situation is if you're playing cards. A pretty common game to use a regular deck of cards for would be like poker. And in poker, you get 5 cards out of the deck. And if you've never really played cards before, here's a quick picture of the 52 cards that are in your standard deck. They are organized by suits, and each suit here has a common name that's used to refer to it. These ones are called clubs. These ones are called hearts. These ones are called spades. And these ones are called diamonds. So if somebody talks about like the 3 of hearts, the 3 of hearts is there, that kind of thing. So for a question here about the probability of getting 5 cards that all come from the same suit, your numerator and denominator here are going to have thousands of possibilities, way more than you could ever really count in like a picture or draw a chart for or list them out. Instead, what we have to do here is deal with things a little bit more abstractly. We have to start by figuring out what the denominator is, of course. And the denominator is going to be the total number of different ways you can get 5 cards out of this collection. Now, that's going to be a situation where you're getting 5 out of a group of 52. You can't replace, because if you've got the same card twice, you must have been cheating somehow and had a card from a different deck. And one really important idea is the order doesn't matter in most card games. There are some card games where it matters which card was first and which one was second and which one was third. But usually in most card games, the order does not matter. Well, if the order does not matter, then we are doing a combinations question. And we've got 52 things we're picking from, and we're picking 5. So, You have a choice about which formula to use. You can use the factorials formula, which would be 52 in the top, 5 factorial, 47 factorial in the bottom. Or the alternative way would be to do permutations, 52 5 over 5 factorial. And since 5 is fairly small, it's probably easier to use this version of it, where we write out the first 5 terms of the factorial for the numerator and stop. And then we have 5 times 4 times 3 times 2 times 1 down in the denominator. So with this, you can do various sorts of cancellation here, like 4 times 3 is 12, and 12 will go into 48 4 times, and for that matter, 2 will go into 4 2 times, and of course 5 will go into 50 10 times, but sooner or later you're going to have to multiply the results together, and you end up getting a pretty big number. You were never going to write these all out one after another. You were never going to make a chart of more than 2 million different poker hands that are possibilities here. So that's how you figure out the denominator, and usually in probability, the denominators are relatively straightforward. You'd work out one fairly straightforward problem and you're done. Numerators tend to be a little more complicated, and in this case, remember, we're trying to figure out the probability of getting 5 cards all from the same suit. So it's probably best to think of one particular suit, like say clubs, and figure out what's the number of ways of getting 5 cards just from clubs. So here you would be picking your 5 cards out of only 13, because there are only 13 clubs in the deck. So this is clubs only. Okay, well, same way we just did the previous problem. We can do 13 factorial over 5 factorial, 8 factorial, or we can do p 13 5 over 5 factorial, which is probably easier. 13, 12, 11, 10, and 9. Oops, that's supposed to be 9, trust me. Over 5, 4, 3, 2, and 1. The 4 times 3 will cancel the 12. The 5 times 2 will cancel the 10. And you end up with 13 times 11 times 9, which is still a pretty big number, but nowhere near as big as what we had before. Then, there's a second step. This was the number of ways to get 5 cards that are all from clubs. There's also this many ways to get 5 cards that are all from hearts, and this many ways to get 5 cards that are all from spades, and this many ways to get 5 cards that are all from diamonds. So, when you're all done with this number, you now have to multiply by 4, because there are 4 different suits you could have been picking your 5 cards from. And it's that second stage of the numerator process that sometimes students forget about. They oversimplify their thinking in their mind, and they're not really considering the whole picture with all the possibilities involved. So here, the probability of getting 5 cards all from the same suit is this fraction here. And since the numerator and denominator are both even, of course we can at least reduce by canceling 2's, and there's probably a lot of other reducing that you'd be able to do here. But remember, this question gave sort of an extra little twist. It said, round to the nearest 100th of a percent. And that's kind of good news and kind of bad news. The good news part of it is you can take this fraction here, plug it into a calculator, and see what the calculator gives you, and that way you don't have to worry about reducing. So in the calculator you get 0.001980792, etc. The problem is that's a decimal, not a percent. So then you have to convert to a percent. Remember how this goes. Converting to a percent is really just a matter of moving the decimal point 2 places. So if you move that decimal point 2 points over this way, you're going to get 0.1980792, etc. And we were going to be rounding to the nearest 100th of a percent, so now you have to round this to 2 decimal places. and we get 0.20%. So 20% of a percent, it's less than 1%. It's basically a fifth of a percent. In other words, getting 5 cards all from the same suit is rare. It's very rare. And in poker, it's considered a very high value result. It's called a flush, and you'll usually win a poker hand if you have a flush. Okay, so basic idea for probability is denominator is the total number of things that can happen. The numerator is the ways the thing you're figuring the probability for can happen. And it's usually a lot smaller, and it's usually a lot trickier. Pay very careful attention to considering all possibilities, and you should be good.